for the following problems, we need to find the solution and the equilibrium value if one exists. Then classify the equilibrium values as stable or unstable. So the first equation here is an plus 1 equals 1 an plus 2, and a naught, the initial value, is -1. If we look at closely here, when we have a system like this, an plus 1 equals r an plus b, then the solution is given by this if r is not equal to 1, and this part is the equilibrium value if r is not equal to 1. But in our question here, r is 1. So when r is 1, then this b should be 0 for equilibrium value to exist. In this case, here r equals 1, but b, that's 2, is not equal to 0. That means no equilibrium value. Okay, if this b or 0, then every number would be an equilibrium value. Next, now we want to solve this system, and again we cannot use this formula because r is 1. So let's try to figure out the pattern. So we're going to plug in a couple of numbers here for n equals 0, 1, 2, 3, 4, etc. So here a naught is -1, that's given. If we take n equals 0 here, okay, if we take n equals 0 in this equation, okay, then we get a1 equals a0, which is -1 plus 2. -1 plus 2 is just +1. If we take n equals 1 here, then we get a2. a2 is a1 plus 2, and a1 is found 1 in the previous step. 1 plus 2, which is 3. If you take n equals 2, we get a3. a3 equals a2, which is 3 plus 2, 5. You don't have to do this. Look at here. The next term is in fact is equal to previous term plus 2, starting -1. Okay, the very first term, initial term, a0 is -1. Now the next term is previous term plus 2. So -1 plus 2, 1, 1 plus 2, 3, 3 plus 2, 5, etc. Then solution is just an formula. So -1, 1, 2, sorry, -1, 1, 3, 5, 7, those are odd numbers starting -1. So odd numbers are 2n plus 1 if we start from 1, but it starts from -1. So 2n minus 1, n equals 0, 1, 2, 3, etc. So this is the solution. Okay, let's move to the next. Now it matches with this form, and r is not equal to 1. Okay, so let's find the equilibrium value first, because it's b over 1 minus r. So equilibrium value is b over 1 minus r, and b is 50 and r is -1.2. Okay, so that is 50 over 1 minus -1.2. That means 1 plus 1.2, 2.2. Divide 50 by 2.2, you get 22.73. And in this question, look at this r. If we find the absolute value of r, that will be a positive number. R is -1.2. If we take absolute value, it becomes just +1.2, which is bigger than 1. That means this equilibrium value is unstable. So we have an unstable equilibrium value. Okay, this is just the formula here. Next we want to solve this system, and here is the solution. So the solution is an equals c, that depends on the previous initial term a naught 400, c r to the n plus the equilibrium value, which is b over 1 minus r, that is 22.73, and that is an equals c to be determined. R is negative 1.2 raised to n, and we just found b over 1 minus r is 22.73. I mean, this would have been the answer, but we don't know the value of c, for we use the initial value a naught equals 400. So using a naught equals 400, so a naught 400, c times negative 1.2 raised to 0, because a naught means a sub 0 means n is 0, and something raised to 0 is 1, plus 22.73. Now subtract 22.73 from both sides, then c is isolated in the right hand side, and c equals 377.2373 27. Thus the final answer, just here plug in the value of c. Thus an equals c is now 377.27 times negative 1.2 raised to n plus 22.73 for all n 0, 1, 2, 3, 4, etc. Okay. Now next problem is similar to what we just did. R is 0.8, which is not equal to 1, so we can still use the same formula like here. So equilibrium value, let's find this first, that is b over 1 minus r, and b is 100 over 1 minus r. R is 0.8, 0.2, so 100 over 0.2, that's 500. And note that this r, if we take the absolute value of r, I mean, this is already positive, so absolute value is also just positive. This is less than 1, that means we get a stable equilibrium. Okay, now the next is we need to find the solution like in the previous question. So solution an is given by c times r raised to n plus equilibrium value b over 1 minus a, and c depends on the initial value a naught equals 1000. So that is an equals c, r is 0.8 raised to n plus b over 1 minus a is 500. Now this would have been the answer, but we need to determine the value of c. So using a naught equals 1000, we get a naught, which is 1000, equals c times 0.8 raised to 0, because n equals 0, a 0, that is 1, plus 500. Now to isolate c, subtract 500 from both sides, so 1000 minus 500, 500. Okay, now go back and plug this value here, and we get the final answer. Thus solution is c is 500 times 0.8 raised to n plus 500 for all n 0, 1, 2, 3, 4, etc. final.